So for this problem, to find the maximum or the minimum value of a function, then from this given, so first we need to find the first derivative. So the derivative of 3y, so this is 3y prime, then equals the derivative of x to the power 3. So this is 3x to the power 2, then plus the derivative of 3x squared. This is 6x, then minus the derivative of 9x, so this is 9. Then for the derivative of a constant, this one is 0. Then from this, so to solve for y prime, so we need to divide every terms by 3. So divide by 3, divide by 3, divide by 3 to solve for y prime. So we have y prime then equals, so this becomes x to the power 2, then plus 6 divided by 3, this is 2x, then minus 9 divided by 3, this is 3. Then from this, we need to equate this y prime to 0. So this becomes 0, then equals x to the power 2 plus 2x minus 3. Then from this quadratic equation, so we can use the quadratic factoring. So to find the factors for x squared, so this is x times x. Then for the factors of negative 3, so this is 3 times 1. So since the middle term is positive, so therefore the sign of the bigger number must be positive and the smaller is negative. So from these two factors, we need to equate this to 0. So this is x plus 3 equals 0. Then the other one, x minus 1 equals 0. Then to solve for x, so x equals, so transpose, negative 3. Then this is x equals transpose positive 1. So these are the two values for x. Then to find the maximum or the minimum, so we're going to use the second derivative test. So to find the second derivative from this first derivative, so this becomes y double prime. So to find the second derivative, so the derivative of x squared, this is 2x, then plus the derivative of 2x, this is 2, and the derivative of a constant, this one is 0. So the second derivative is 2x plus 2. Then from this second derivative, so we can substitute now the values for x. So for x equals negative 3. So this becomes y double prime then equals 2 times negative 3, then plus 2. Then we have y double prime equals, so this is negative 6 plus 2. So y double prime equals negative 4. So since the value for the second derivative is negative, therefore this x equals negative 3 is the maximum value. Then for the other value for x, so at x equals positive 1, so again from the second derivative, so this becomes 2 times 1, then plus 2, or y double prime equals 2 plus 2. So therefore y double prime is equal to positive 4. Then from this, so since the value for the second derivative is positive, so therefore this x equals 1 is the minimum value.